slots. I'm more tuned into 50-minute slots. Do what we can. Go to, let's see, I guess I can change here, right?
Yes. Downward. Okay, we'll change it. We'll change it.
Here, it works nicely actually.
Oh. Oh, okay. It was a challenge for me to come up with a talk because I had never worked on synchrophasors. I understand them, but I had never done work on them. And so I thought, well, besides, these meetings are about reminiscing with old friends about things that we've done in the past. Besides, Fred Schweppe once told me that that the only certain thing about predicting the future is that you'll be wrong, so I didn't want to go there. So I thought, well, what am I going to do? Well, Jim and Arun and I actually worked on a project together for quite some time back in starting in 1981. Arun was on his way from New York, AEP, to a position at Virginia Tech. We wanted him to stay at Cornell. He spent the summer there, but he said, this is too cold. I'm going somewhere where it's warm. So off he went to Virginia Tech. The project didn't involve synchrophasors. And besides, there's nothing I could say that would enlighten them at all about that field. So I wanted to also highlight the breadth of both of their contributions over their careers, because their contributions have been enormous, even outside the area of synchrophasors. So their contributions to the topic of this talk is probably not very well known. So I thought I would go ahead and do this. So back to the future, 1981. I had been at DOE on my first sabbatical in Washington. That's where I met Phil Overholt. He and I shared an office starting down near Union Station, where DOE had just been formed, and then moving on to another building in Washington. This tiny little office, no windows. And at that time, there had been the oil embargo, and the U.S. was interested in renewable generation. Feature that in 81. And one of the areas that we were looking at was wind back in 79, 80, 81. There was a whole group in DOE that was building wind turbines. And I was asked to go with another fellow at DOE to talk to them because they thought they were ready to interconnect to the utility grid. They built these 2.5 megawatt wind turbines. They wanted to plug them in. They said, well, how are you going to do that? And they said, well, you just hook up a cord and you plug it in, and away you go. That was the concept. So when I left DOE, Charlie Smith, who many of you know, was running a group there, and he says, well, you're going back to university. We kind of like what you did while you were here. How about if you just go back and do something that you'd like to do, and here's some money. A lot of money. So, well, you know, what I really wanted to do was work on variable speed wind turbines because my background was in electromechanics at that time. And I wanted to figure out how to hook this thing up to the grid in a better way. And so talked to Jim and Arun about doing something together, and Arun said, well, you know, these are pretty good sized machines, but did you look at the protection issues? And I knew nothing about protection, and of course that's the area he was with. The other thing that he is a real expert in is high voltage DC. That's really where his background was at that time. And so we looked at the protection, and he said, look, if you're going to protect the system, you have to protect it using standard utility practices. So let's look at how big a farm do you want to build. So, well, 100 wind turbines, 2.5 megawatts each, 250 megawatt clusters. That's what we like to start with. He says if you look at the fault current for something like this, you know, you're talking about a generation voltage of 4.8 kV, 100 of these 2.5 megawatt machines, you're likely to see a fault current of about 78 kiloamps, which at that time was beyond breaker technology. So how are you going to do this? You had to, in effect, you had to protect every one of these little 2.5 megawatt wind turbines as though they were a 250 megawatt generating station. And if you look at the cost of doing that in a conventional hookup with large clusters like this, it was something like a third of the cost of the installation of the entire installation. The protection costs were enormous. So what could you do? Well, there was another calculation that we were making, and this was Jim's area, and that was why would these uncertain machines be put into a system? Wouldn't they be a real problem to operate with this kind of uncertainty? Well, it turns out, and this was a calculation back in 1980, that clusters are good. Lots of small things are better than one big thing in terms of the uncertain, when you have uncertain inputs, because the variance to mean ratio for one machine, you can scale that by a factor of 1 over the square root of n, where n is the number of machines, and you can in fact decrease the uncertainty of the penetration. This is fairly revolutionary. The wind people like this. So these are, by the way, the Mod 2. This is a cluster that they were building at the time, which is 3 machines up at Goodnoe Hills. And Boeing actually built these machines and were ready to put a bunch of them into the grid. I was interested because they were building those machines as fixed rotation machines. They thought they had to operate at some multiple of 60 hertz because they were going to hook a generator into a 60 hertz system. So they actually synchronized these things, had little blades on the tips, so they could control it to a constant speed no matter what the wind speed is. But yet if you look at these the equations for power and torque, there's this factor Cp in there, which is a turbine power coefficient, and it looks like this, and there's a maximum to it. That's a ratio. What that says is that you ought to operate these things at a rotational speed that's proportional to the wind speed at that time. You would capture a whole lot more wind, a lot more. So I was really interested in this problem. So this all fit together. So how do we take care of all these properties and hook them up? And Arun suggested this. He says, how about if we hook this up with DC and we'll put them all in series? I mean, you ever think about a series interconnected high voltage DC system? I thought this was just incredibly smart. I thought, wow, this is really interesting because it takes care of almost every problem. You know, you could operate these things asynchronously. You can protect them. You can use standard high voltage inverter technology at the AC interface. This is really good. And there's a lot of really interesting control problems here. So Arun came to Cornell in that summer in Kasum, and we spent the summer, Jim and Arun and I and students, working on this interface, on the variable speed drives and so on. And worked out the control of the interface, worked out the induction machine drives for the AC for the variable speed operations, and got the economics of the system down to something reasonable. And it was just it was an incredible summer. And in addition to that, two other things. Arun and Jim work together on the Kettering lab, and we're working on some of these protection things. And but more importantly, that summer was one of Jim Thorp's hole-in-ones at the golf course. How many do you have? Only one? So that was Jim's hole-in-one year, as well as, it was a great summer. Anyway, there's a whole list of advantages to this thing. And in the contributions, I'll start at the bottom. I worked on this variable speed thing with my student Jim Lyons, who some of you in here know, who eventually went to GE, and this work became the basis of the GE wind turbine design that's out there today. Jim worked on the spatial temporal wind model, which was the first time anybody had developed a spatial temporal stochastic model for wind farms. He took data from Rocky Flats. This is 2-second data at 7 sites, synchronized data, and worked with that data to develop the model, which was, again, an incredible piece of work. Along with looking at adapting AGC with wind penetration and so on. And of course, Arun, with this high voltage DC link that he had come up with a series connection and developed the controls and harmonic analysis, insulation, all that sort of stuff that Arun is really good at. So it was a great summer and a great project, and I thought, wow, we're in the wind business because we're going to revolutionize the world. So what happened? Well, we suggested when we got all this stuff figured out that we do a demonstration. We're going to build something. We're going to go out there and build it. And what happened? Well, the people in the Middle East decided that they didn't really need all that money for oil, that they could do with less. So the price of oil dropped a lot. The U.S. then said, well, what do we need wind for? We got lots of oil. So just completely lost interest in renewables, wind generation, and all the rest, and moved on to other things. Boeing, who built the Mod 2 wind turbines, of course, they built the 787 Dreamliner, complete with batteries and other things. And NASA, who was, at that time, they were out of the space shuttle business and were looking for other things to do, and so they were in the wind business as well. And so they got back to the space station, and everybody went on to do other things. I have often thought on this project that it really was revolutionary, and we should have built a demonstration. But just to tell you and Arun and Jim in particular, these are January 2012. You'll notice that in the wind area, this is Charlie Smith basically at UWIG saying that the thing we need is we need high voltage DC. We see there's a Atlantic Wind Project. They're connecting up 6 gigawatts of offshore wind. It's all going to be high voltage DC. Probably not the series connection, but which is too bad. And here's the New Jersey link that is going to be 3,000 megawatts. There's some really interesting interconnection problems. This is at a workshop here in Washington about a week and a half ago on high voltage, future high voltage DC. So, must be the end. Anyway,
it is that.
That's it. My bottom line takeaway from all of this is that to Arun and to Jim, A, it was a pleasure and very enlightening over the years, and B, now that you got all this Synchrophasor stuff sorted out, a little longer than I thought it would, but you know, now that you have it sorted out, I'm ready to go back into the wind business. So whenever you're ready, let me know.